What's up everyone? If you are a plugin developer and you want to add Temposync or beat related parameters to your plugins, then you should stay tuned because I will show you how I did it, and maybe you will do it the same way or similar way or a completely different way because you don't like the way I'm doing it. Also, I used this opportunity to test my new green screen setup. Check out how nice I am, just not part of my room but part of this code. Whoa, damn. It doesn't look perfect, but that's because of the lighting and stuff. I don't have a better solution for lighting yet, so that is just how I look like. But is this at least better than just seeing my room in the background? Or is it too confusing that I'm sort of a ghost now? That is the question that I'm asking you. Anyway, let's get started. So first of all, I want to show you what is going on here. So these are no Temposync measures here. As you can see, it is milliseconds, but I can click on the Temposync button and at that moment it will be Temposync values. And as you can see, you can scroll through them starting from 0, then 64th notes, then triplets and 64th dotted, and then it goes on with 16th, 8th, 4th, halves, whole notes and positive values like 2 bars. So there are already multiple accomplishments in this implementation, which is first of all that I have whole notes, triplets and dotted notes all in the same parameter, because I always find it annoying when that is not the case in plugins. Sometimes it can be useful if that is at least turn offable, because then you can make modulations that maybe are just with the whole notes or stuff like that, and you can just skip over the other things. But I don't need that here because this is just an ADSR. And the other accomplishment is that the value can be 0, because a rhythm of 0 length is actually kind of a weird concept, but it makes sense in the context of an ADSR because it means that we are skipping the attack state. So it's important that this exists. So as you can see, this is my parameter creation moment in my code base, and even if you don't use the same parameter methods that I'm using here, like my make parameter free function, you can still see what's going on, and from that you can just make yourself a similar function. So we are creating a parameter here, the attack beats, decay beats and release beats parameter, which is different from the normal attack, decay and release parameters. And I make this distinction on purpose because you might be tempted to think that it's good to have less parameters, but just a generic attack, decay and release parameter that can just change the way it displays the range. But I like it more to have it separate, not only because it's easier to maintain code like that for various reasons, but also because if the user decided to actually modulate the Temposync button, so they want to switch between Temposync and other types of units, like in this case milliseconds, then they can have separate settings for, say, the decay times of each, and they don't have to write a decay automation at that point because they already set up the settings in each of the parameters already, which I find to be a nice workflow. In the rare case where someone really wants to modulate the Temposync button, which can be, but I never saw someone doing it, so I don't know. So it's quite an edge case. So then we have a default value of 1/16 notes, so that is very understandable. And we have this range function, which I will be talking about very soon, which gets us 3 different values. So the 64 stands for the lowest value that is not 0 is 1/64th, and the 0.5 stands for the biggest value is 2 bars. So you know that this is like 1 divided by 0.5 rhythm. So that's 2. And the boolean is for whether or not it should have a 0 at the start. Yeah, and then I'm giving it my beats unit because that's in my code base that makes sure that the value true string functions and String-ToValue functions are set up correctly, so that you can enter something that resembles a beat string and then it will give you the correct value and stuff like that. So let's check out the beats range. As you can see, it returns a range, which just means juice normalizable range float. So the first value is what comes into the minimum denominator and the maximum denominator, and then with 0. As you can see already, I solved this by making a lookup table. I wanted to do this purely algorithmically first, but that was just too much of a pain in the... So I just decided to take a step back from that and just fill a table with the values that I need and then go from there somehow. And that turned out to be quite easy and actually pretty elegant as well. Probably even computates better, so I should not be sad about this solution. So first of all, I wanted to solve a very simple problem, which is how big should this table be? How much space do I have to reserve for this table? And in order to find that out, I had to create new values from min dominator and max dominator, because things like 16 or 0.5 don't really say a lot about how long this parameter should be, how many values are in there directly, but you can just apply log2 to both of these parameters, and then they become something that you can work with much easier. For example, if you had 16 here and 0.5 here, then that would result in min value being, I think it was -4, and this would be 1 or so. Or was it 4 and 1? I don't know anymore. I just know that when I tried to subtract one from the other, then that gave me the number of whole beats in the range. So that would be 16th, and then 8th, and then 4th, and then halves, and then wholes, and then 1. I also made an inverted version for that, but as you can see, that only comes later. And I also casted it to int, because you don't want to know what is the number of whole beats, but what is the number of all beats. Fortunately, that is a very easy calculations, because for every whole beat there are 2 other beats, which is the triplet and the dotted. So we can multiply this value with 3, and we say also +1, because the last value that just comes at the end is just the end value. Say you have a range that goes from 16th to 8th, then that would mean that you basically just have 16th triplet, 16th dotted, plus the 8th whole. You don't have all of the 8th values, you know. And then you also add 1 if 0 is enabled for the start. Now you know how many values to reserve in your table, so you do that. And yeah, if you are putting 0 in it as well, then you can directly start by emplacing back a 0, and then the fun stuff begins. We are looping from 0 to num whole beats, so we are going in whole beats again, and we are calculating the x value for the current I value, which means a value between 0 and 1 that we can use in this calculation here for cur value, which is basically the same type of unit as min value and max value, because that is the kind of stuff that we can convert into the value that we want to use, which I call base value, by using the power of 2 to the cur value. I cannot really describe why that is the case. It is just something that you find out with experimentation when you are working with beats and stuff a lot. And then at some point you just notice you always have to use log2 and power all the time. And then you try that on everything until it works. Now from there it's very easy to come up with the actual values that end up in the denormalization table, which is for the value whole just 1 divided by base value, for value triplet value whole times, well, this, and then for the dotted it is value whole times this. And then you emplace all of them back, and at the end you also emplace back 1 divided by the max denominator. I want to quickly take a step back from my range implementation. Now we're here in the value to string function. What I want to do now is I want to return the string with this value directly instead of all of the other things that are going on in here, to just show you what kind of values this parameter exactly has. Now you can see the actual values that are in this parameter. For example, when I go to 1 bar, then this is 1. When I go to 2 bars, this is 2. When I go to half a bar, then this is 0.5, and then it goes on 0.25, stuff like that, because that is actually the type of number that you can use in a lot of DSP when you are trying to multiply this with a BPM and stuff like that. And this is exactly the kind of stuff that you want to see there. And so that's why I designed my range method to work like that. But of course, it is just painted in a very different way. You want to see this layout with the numerator and the denominator, so I wrote this entire function. Anyway, let's get back to the range, because we weren't done here yet. So as you can see, this is the part of the code that returns the range, and the minimum value is the start of the table, the maximum value is the end of the table, all easy from here. Now in the denormalization function, we're just multiplying the normalized value with some cryptic value that is explained here, using that as an index for the table. And for our normalization function, we're just looking at the entire table, searching for the current denormalized value, and if we found it, then we are returning it times some cryptic value from up here again, and else 0 if all of this fails for no reason. Actually, it cannot fail, but you know, this is C++ and you always have to have a return value just in case. The function that just says whether or not this is legal, well, it I kept it simple. Now what is up with this cryptic values? This is actually very important. We have this epsilon value, which is actually 1 minus numerical limits epsilon. If you don't know it, it just gives you a really low value for your given type. This basically means it is a value that is very close to 1 but a little bit lower, and by multiplying that with the num values we get something that we can multiply with the normalized value, and it will not reach 1, so we cannot overshoot this index, which is nice. Then we also have to make the inverted version of that, 1 divided by num values times 1 divided by epsilon, and that way we kind of make the inverted thing that we can multiply with the index value from our normalization function in order to, you know, compensate for the fact that we did this at denormalization. And even though that might sound a little bit fragile, it actually works like a charm. Now we could spend some time with the value to string function, but I gotta say I have not checked all of the edge cases yet, so you have to take this with a grain of salt. Also for the String-ToValue function when I get to it. Anyway, let's get started. So what's going on here? We get an input value and we want to have a string, namely we want to have a numerator, a denominator, and a mode string, you know, which is the T or the P at the end of the string that is being painted. To make this more clear, I'm specifically talking about the thing that happens when I'm hovering my parameters, which is that it does not show the name anymore, but the value of the parameter. So this function makes sure that this is drawn in a nice way that everyone understands. So what's going on here? So first of all, I'm checking if the value is 0, because if it is, then a lot of this kind of stuff will not work anymore, especially not this. In that case, I'm just returning the number 0 and nothing else. Then I'm calling the next lowest power to x function, which is a function that is defined as the power of 2 to the times of floor of log x of x. Yeah, and that gives you a value that you can work with, because this value that you're getting here, it is a denormalized value, but just from getting some random number that looks kind of cryptic, you cannot really see if it's a triplet or a whole node or a dotted node. So you have to find that out, and you're doing that with this calculation, because then you can get the fraction by subtracting the value from denorm floor. I call this denorm floor because it's kind of like flooring, which is why I have this line here, getting the fraction between that looks a lot like floor. This is not actually a floor, because we are talking about values way below 1 here, and it's not going to put it on 0, but on something that just makes sense in the context of 2 to the power of x thingies. That's why I called it like that. And when you then just divide the fraction with the floor, you suddenly get a value that makes a lot of sense, because if it is 0.666666667, then you know that it's a triplet, and if it's 0.75, then you know it's dotted, and else it is whole. So you can just define that then, and then you can at that point already define the mode string, obviously. Now you just have to figure out what to do to get the denominator and the numerator. And I just did it like this. I said that denominator is 1 divided by denorm floor, because obviously the denominator, it always just shows the whole value, like 16 and 8 and 4, so we use the denorm floor variable for that. And normally the numerator is just 1, but it can be that we have values that are above or equal 1 bar, and in that case the denominator is smaller than 1, and then we're just doing these things. We are setting the numerator to the denorm floor instead of something with the denominator, and the denominator becomes 1. So it's kind of like a bit like the other way around, and yeah, and that just solves the thing. Now we have the String-ToValue function for the beats, and I just saw that my webcam is actually set up in a really bad way. I mean, I took all this care with the green screen and everything, and then I'm like down here. But yeah, I have to still figure out how to make this most comfy. I don't want to do that now. The String-ToVal function has the goal to let the user type in a value, and then it will figure out where to place the parameter. Und dauert das so lange? It takes so long to compile. Oh no! Why does it take so long? I don't want to wait anymore. Come on, let's go! Yes! Alright, enough of these super nice special effects. Now let's see it in action. I'm pressing Ctrl click on my parameter to type in 132th dotted. Let's go. So does it work? Yeah, it works. Nice. Let's go. So how does it work? I'm looking at the last character in the string, and if the last character has T in it, then I know that it's triplet, and else it is a dot, so it is dotted. None of these, so it is beats. So we have this text. If we're in beats mode, we can use the whole text, and else we just use almost everything except for the last character, obviously, because it is T or dot. And then we can actually put the text into a formula parser. Now, unfortunately, writing a formula parser is a very complicated problem, and I think I have actually made a video about that already, but I should make a new one because I rewrote the thing at some point, and it's actually pretty cool now. For now, I will just tell you how this works. This is my formula parser, and it has two arguments, the text and the default value. So if anything fails in here, then it will return a 16th note, and else it will return whatever value it creates. So it returns that value, and then if we are in triplet mode, we are also multiplying this to it, and in dotted mode we are multiplying this. So you have seen that before, I don't have to explain that. And then we can return the value, and as you've seen, that works. Alright, so I just want to quickly show you an example of how you can use a parameter like that in practice, so that you know that I'm not talking nonsense about wanting to have the Temposync parameters like this. So this is the method that processes my envelope generator, and I'm going in here with a playhead and with attack decay and release beats and with the Temposync switch. So basically asking if Temposync is enabled and if your playhead actually works, which in my case is defined as the BPM not being 0, because I defined my playhead position's default BPM to be 0. So if it was overwritten at any point, then it must have been because the DAW actually has a playhead with a BPM, so it is not 0 anymore, and then it can actually get started if both of these conditions are met. We're getting the beats per minute, we're getting the beats per second by beats per minute divided by 60, and the samples per beat by sample rate divided by beats per second. These are just calculations that you can come up with when you're playing around with this kind of stuff a little bit, so that's not really hard, even though it might look a little confusing at first. Whenever I have to deal with this kind of stuff, I have to open another Desmos again as well, so it makes sense to be a little bit confused. Now this might look a little bit cryptic, but this basically just says if attack beats is 0, then we can just smoothen the parameter with a value a little bit bigger than 1, because my ADSR is just implemented to skip the attack state then. And else attack beats is not 0 means we want to have the increment value from these values now, which just means we are taking the parameter value that we get straight from the parameter denormalization function times the samples per beat that we calculated from the BPM here very easily, and then we just divide 1 by that value, and that's already our increment value. The parameter values that come from this parameter are really directly usable in your DSP code. You can just instantly slap them at stuff and they work. Alright everyone, I hope you enjoyed my little coding tutorial. I hope that when I'm testing a lot of plugins in the future that have Temposync features, that they all are very nice now. Nice ranges, nice string to value, nice value to string and stuff like that. I want to see that now. I want to have more plugins with nice Temposync features. Let's go.